Have you ever just looked at a mountain range and thought, how in the world did that get there? I mean, it's not just a random pile of rocks, right? It's a story. It's an epic story of incredible heat, mind-bending pressure, and just vast, vast stretches of time. And in this explainer, we're going to learn how to read that story, a story that's literally written in stone.
So let's start with a bit of a mystery. What you're looking at is a satellite view of the Peninsular Ranges down near San Diego. You can see these really rugged mountains and how they kind of give way to a flatter coastal plain. And then you've got this dry, arid basin off to the east. It's a super complex landscape. So the big question is, why? Why does it look exactly like this? What forces came together to shape this very spot?
To crack this geological case, we need to learn the language of the land. Think of it like being a detective, you know? You're searching for clues that are hiding in plain sight. So how do we actually learn to read this incredible storybook? Well, first, you've got to meet the main characters.
Yeah, our investigation has to start with the absolute fundamentals. What is all this stuff made of? These are the characters that are going to show up in every single chapter of Earth's long story.
You know, pretty much every rock on Earth falls into one of three main categories. You've got igneous rocks, which are born from molten stuff. Then there are sedimentary rocks, which are basically made from little broken pieces of other rocks. And finally, metamorphic rocks, which are old rocks that got a total makeover from intense heat and pressure. Let's kick things off with igneous. The name itself comes from the Latin word for fire, which makes perfect sense, right? Anytime you see a volcano erupting, you are literally watching igneous rock being made, either as ash shooing into the air or as lava flowing down the side. These rocks are, for sure, the fundamental building blocks of our planet's crust. Okay, now this is really cool. The speed at which that molten rock cools totally changes what it looks like. When lava erupts and cools super fast on the surface, its crystals stay tiny, making a fine-grained rock. But when magma cools really slowly, deep, deep underground, it forms these big, chunky crystals you can easily see, like in a granite countertop. And that difference, that's a huge clue for a geologist. Big crystals tell you this rock must have formed way underground, where it had millions of years to just hang out and cool down. That's a critical piece of the story. And here's the thing. These characters are always changing costumes. The rock cycle here shows how any rock can become any other type of rock. It's amazing. Let's trace it real quick. An igneous rock on a mountaintop gets broken down into tiny pieces of sediment. That sediment gets washed away and settles somewhere else. Over a long time, it gets buried and squeezed, becoming a sedimentary rock. If that rock gets pushed even deeper, the heat and pressure can transform it into a metamorphic rock. And that rock could eventually melt back into magma, and boom, the cycle starts all over again. It's a nonstop process of transformation.
All right, so we've met our characters, the rocks. Now let's get into the plot. Let's talk about the powerful forces that are constantly reshaping our world.
Now, it is really important to get the difference between these two terms. Weathering is the process of breaking rocks down. Just think of a sledgehammer cracking a boulder into smaller bits. That's weathering. Erosion, on the other hand, is the process of moving those broken pieces. It's the truck that comes and hauls the rubble away. So what are these agents of erosion, these forces that move everything around? Well, first there's just gravity. It pulls loose stuff down a slope, which is what's behind every landslide. Then you have flowing water, like rivers that can carve out massive canyons. Glaciers, these giant rivers of ice, can gouge out entire valleys. And of course, wind, which can move incredible amounts of sand and dust. This is just a perfect example of the power of these forces. I mean, it seems so small, right? A single grain of sand. But over thousands and thousands of years, the simple act of wind blowing that sand around can create enormous, constantly shifting landscapes like these dunes. It's a powerful reminder that tiny actions, when repeated over huge amounts of time, can have incredible consequences. Okay, so we know what the landscape is made of, and we know about the forces that shape it. But to really get the whole story, you have to be able to read the timeline. You have to put all the events in the right order. This right here is our #1 tool for reading the rock record. It's called the principle of superposition. And it's so beautifully simple. Unless something has come along and messed them up, the oldest layers of rock are always at the bottom, and the youngest ones are on top. It is the golden rule of geology. Think about it like this. Sediment, whether it's at the bottom of a lake or an ocean, pretty much always settles in these nice, flat, horizontal layers. Each one of these layers is like a page in a history book, capturing a snapshot of a moment in time. But of course, our planet is anything but static. Tectonic forces can come along and squeeze, bend, and tilt these rock layers. This process is called deformation, and it's a major plot twist in our geological story. Those once neat, flat layers can get tilted at a crazy angle or even folded completely over on themselves. Okay, little pop quiz. Even if these layers are tilted up like this, does the principle of superposition still apply? Which layer had to be there first for all the others to be piled on top of it? Okay, we've met the characters, we've learned about the plot, and we know how to read the timeline. Now it's time. Let's put it all together and solve our mystery, the case of the Peninsular Ranges. And here we are again. But this time, we're not just looking at a pretty picture, are we? We're looking at a crime scene, full of evidence. We have the tools now to figure out what happened here. So let's zoom in and see what clues we can find. So on the left, you see these big, rounded boulders. And on the right, you've got this mix of sand and pebbles. These are not just random rocks, these are clues. The type of rock tells us how it formed, and all that loose stuff tells us what's happening to it right now. So let's piece this story together. The granitic rocks, with their big crystals, tell us that a massive body of magma cooled down really slowly, deep underground. The steep mountain faces tell us that powerful tectonic forces push those once-buried rocks way up, forming mountains. And all that loose sediment we see? That's the proof that weathering and erosion are, right now, in the process of tearing those very same mountains back down, one grain at a time. And by the way, this process is what creates hazards like rockfalls and landslides in places just like this.
And that really just sums it all up, doesn't it? Every single feature of a landscape, from the type of rock under your feet to the angle of a hill, it's all just a word on a page, telling a story that goes back millions and millions of years.
And that story is not over. It's still being written, right now. The forces of uplift, weathering, and erosion are at work all around us. So next time you're outside, take a closer look. What clues can you spot? What story is the landscape around you trying to tell?